All right, so today's learning target is I can solve linear equations with variables on both sides of the equation. So again, we talked about it before, sides of an equation means that the equal sign is where the wall is. It splits your left side up from your right side. With variables on both sides, you'll notice that I have an x term on the left as well as on the right. You aren't able to have that when you've got a situation where there are variables on both left and right side. You have to maneuver it so that the variable is just on one side, or shift it so the variable is just on one side. So if I'm moving a variable term like 5x from the opposite side of the equal sign, then you're going to have to add or subtract. I know a lot of times people look at this and they're like, oh, negative 6x, I'm going to divide. Or, oh, 3x, I'm going to divide. When you're moving the x as well, not just the number, but you're moving the x along with it, that is addition or subtraction. To move terms, full terms, to opposite sides, you do addition or subtraction. To keep a variable where it is and just get rid of the coefficient or divisor, that's when you use multiplication or division. So just make sure you keep that in mind. I tend to say focus on the smallest of the variables to help you avoid those negative coefficients. So if you're trying to figure out, well, which one am I supposed to move? Am I supposed to move the negative 6x, or am I supposed to move the 3x? It really doesn't matter which one you move. I could add 6x to both sides, or I could subtract 3x from both sides. It doesn't matter, but I tend to suggest moving the smallest of the variables so that way it eliminates having a negative coefficient. So if I were to move a negative 6x to the opposite side, then that means I'd be adding a 6x to both sides. It leaves me with a positive 9x. Versus if I were to move the 3x, I would have to subtract 3x from both sides, and then I'm dealing with a negative 9x. A lot of times people make mistakes with those negative coefficients, so that's why I say err on the side of caution. Just always move your smallest one. And then it gives you a rule to follow, okay? So let's take this example that I have here. We're going to work it out. So the first thing you always should do before you ever start solving is to see if you can simplify by distribution and combining like terms. I don't have anything to distribute on the left side. I don't have anything that needs to be distributed on the right side either. I don't have any like terms on the left side, and I don't have any like terms on the right side. So it's as simplified as it's going to be able to get. So now I start the process of solving, which means the first thing I'm going to do is pick the variable to move. So like I said before, I tend to focus on moving the smallest of the two variables. So I'm going to go ahead and I'm going to add a 6x to both sides. Now notice I'm only going to put the 6x underneath where the 3x is because I'm combining like terms at the same time as simplifying or solving. These 6x's are now going to go ahead and get boxed off. What I'm left with is I'm still left with a positive 12, and it's equal to that 3x plus the 6x now becomes 9x, and then I still have that minus 15. So I now have this expression, equation. Now again, if you want, you can rewrite it so it says 9x minus 15 is equal to 12. It really doesn't matter, it's up to you. But I'm down to a two-step equation. That's the goal. You're trying to simplify these things as much as you can so that it gets down to a two-step equation, where I would add 15 to both sides. Those 15s would get boxed off, and I'd add 15 to the 12. That now leaves me with a 27 is equal to 9x. And then from here, I'm going to go ahead and divide both sides by 3. Or by 9. Whew. Okay, when I divide both sides by 9, I get 3 is equal to x, or I can just write it as x is equal to 3. Huh? It's not complicated. It's very, very simple. Complicated is later. Okay, so let's try this one, problem number 2. Again, First thing I need to do is see if I can distribute anything. Is there anything that can be distributed with problem number 2? No. Okay, next thing I'm going to do is I'm going to look at the left side. Can I simplify by combining any like terms here? Nope. What about on the right side? Can I combine any like terms on the right side? No. So now I can start solving. I've got a variable on both sides, so I need to move one of the variables. Like I said, it's easier if you choose the smallest of the two variables. Which one is smaller, a positive 8x or a positive 5x? Logan? Positive 5x. So instead of having a positive 5x, I'm going to do the opposite, which would be to have a negative or subtract my 5x. So the 5x's are going to get canceled out. I'll zoom in so it's easier for you guys to see. Okay, now I'm going to do 8x minus 5x. What is 8x minus 5x going to give me? Come on, guys. What is it? 3x. So we have 3x. We still have a plus 7 that needs to come down. Equals, and that's a positive 19. Okay, from here, it's a two-step equation. What am I going to do first? What's the first inverse operation, Zachary? Minus 7. We're going to subtract 7 from both sides. So 7s are going to get canceled out. Okay, we're now left with 3x is equal to 12. Okay. Last step. What is the last step that needs to happen here, Fatima? Good. We're going to divide both sides by 3. And that's going to give us x is equal to 4. Okay. So those are the easy ones. It does get harder. So I'm giving you an example of a problem that's probably as hard as it's going to get, and that would be problem number 3. Number 3 is going to be as difficult as you can experience. I strongly suggest that you write everything down that I write and that you utilize that when you are doing your Delta Math today, because you are going to have problems similar to problem number 3 on your Delta Math. Okay? So let's take a look at problem number 3. What do I say is the first thing we always need to do? Check for distribution. Do I have distributive property here? Yes. In fact, I've got multiple distributive properties that are going to happen. I have this 1/2, that's a positive, that's going to get multiplied to this 8x, and it's going to get multiplied to this negative 1. I also have a positive 6 that's going to get multiplied to this 4/3 x, and it's going to get multiplied to this negative 1. That means there are several things that are not being affected at all. For example, this negative 3x is just going to come straight down into the next part of my problem. Now I need to actually multiply. I'm going to do 1/2 times 8x. 1/2 times 8x is going to equal positive 4x. I need to also do 1/2 times negative 1. 1/2 times negative 1 is going to come out to a negative 1/2. I have my equal sign that's going to come straight down. I have this negative 1/2 that's going to come straight down. The next portion I've got is this 6 times 4/3 x. 6 times 4/3 x is going to be a positive 8x. We also have this 6 times negative 1, and that's going to come down as negative 6. Okay? We have done our distributive property. Distribution is all complete. The next thing that we need to focus on is what? Hassan? Combining like terms. Let's focus on the left side of our expression first. The left expression. Is there anything here that we can combine together? What is it going to be, Logan? Okay, this negative 3x and this positive 4x can get combined together. Negative 3x plus 4x is going to come out to a positive 1x. Do I have to write the 1? No, I don't have to write the 1 at all. So that's a positive 1x. There's nothing else that can be simplified, so it's just going to come straight down as a minus half equals. What about on the right side? Is there anything on the right side that can be simplified? Richard? The negative 1/2 and the negative 6. So if we do negative half minus 6, that's going to come out to a negative 6.5. That comes out to negative 6.5. We still have this positive 8x that does not have a like term with it, so it's just going to come down as positive 8x. Okay, we have distributed. We have simplified our left side as much as we can. We have simplified our right side as much as we can. Now I need to note that there are variables on both sides. Which variable should I go ahead and move then? Hassan? The x. I'm going to subtract a 1x from both sides. I'm going to go ahead and write the 1 now so that way I know the reason I'm subtracting just a 1. Because a lot of times when people go, oh, I'm subtracting an x, they're like, oh, it's just 8. But it's not. You're subtracting 8x and x, which means it would be 7x. Okay? So be very mindful of that. Those are going to get canceled out. We now still have a negative half is equal to a negative 6.5 plus 7x. Okay, from here, it's a two-step equation. What are we going to do first? It doesn't matter that it's fractions. Zachary? Nope, not plus 1/2. It's plus 6.5. We're going to add 6.5 to both sides. So I'm going to add 6.5 over here. Okay, these are going to get boxed off. They're gone. Negative half plus 6.5 is just 6. So 6 is equal to 7x. What's my last step? What's my last step going to be? Maggie. Maggie, what's my last step going to be here to get x by itself? By 7. We're going to divide both sides by 7. So the 7s are going to go ahead and simplify out. And what we're left with is x is equal to 6/7. That's it. It's okay to have a fraction answer. It's okay to be like, hey, I don't really want to divide 6 and 7 because it's going to give me a long drawn out decimal. So I'm just going to write it as a fraction. This will be perfectly acceptable. Okay, Richard. It doesn't matter, but I would say leave it in fraction form because it gets you prepared for our future units, which you'll have to leave them in fraction form, even if they're improper. Okay? So I would say for today's assignments, leave all of them in fraction form. Even if it's an improper fraction, leave it in improper fraction form. Yeah. Leave it in fraction form, unless it's otherwise stated. So if the question gives you decimals, then do decimal form. But if you're getting fractional answers and you were dealing with originally whole numbers or other fractions, leave it in fraction form. Okay? All right, let's take a look at problem number 4. I'm going to draw a nice little box over here so that way we know it's different. Okay, first thing that I need to do, very first thing, what is it going to be? Let's call on, wow, okay, Amy, distribute we're going to distribute. We are going to do 2 times the x and 2 times the positive 1. 2 times x and 2 times 1. That's what our focus is going to be. 2 times x, God bless you, is 2x. God bless you again. And then 2 times 1 is a positive 2. Okay, there's nothing else on that right side that can come down, so we're just going to bring our equal sign down. Everything else on the left side is going to come straight down as well. So negative 5 plus 7x minus 3. We've done our distributive property. Okay, next step, combine like terms. Let's focus on the left side. Like terms on the left side. Let's go with Liana. Liana, what left side like terms do we have?
Negative 5 and negative 3.
Good. So we have negative 5 and negative 3 that can get combined together. If we do negative 5 minus the 3, that's going to come out to a negative 8. Okay, we don't have any like terms with that positive 7x, so it's just going to come straight down as a positive 7x. Okay, what about on the right side? Do I have any like terms on the right side, Montserrat? No. We have no like terms on the right side, so everything just comes straight down as 2x plus 2. All right, I have variables on both sides. I don't like having variables on both sides. Let's move one of those variables. Which variable should I go ahead and move, Merrick? Variables. Which ones are the variables? Negative 8's not a variable.
2x.
The 2x, right? We have a positive 7x and we have a positive 2x. Let's go ahead and move this positive 2x. Okay, so I'm going to subtract 2x from both sides. Okay, by doing so, I'm now going to have a negative 8, because that's going to come straight down. 7x minus 2x is going to be a positive 5x. So I put plus 5x. And it equals, this positive 2 comes straight down as just a 2. All right, from here, Leah, what's the first thing that we need to do? The two-step equation, what's the first inverse operation that we need to do to solve? I can't hear you. Plus 8 on both sides. Okay, we're going to add 8 on both sides. This minus 8 and this positive 8 are going to go ahead and cancel out. We're going to be left with a positive 5x is now equal to a positive 10. All right, my last step, what am I going to do from here? Go ahead, Fatima. Good. We're going to divide both sides by the 5, and we'll get x isolated. X is going to be equal to a positive 2. Okay? All right. You've got a couple practice problems to try on your own. I want you guys to try it independently. I'm going to give you about 10 or 15 minutes to work on that before I display what the solutions are. If you finish it before I go over it, then you can get yourself logged in and working on Delta Math. Okay, so for problem number 5, you should have gotten x is equal to 5. Here's why. You would distribute the negative 3 to come out to negative 3x minus 12. You would then add the 3x to both sides. 2x plus 3x gives you 5x, so you now have negative 12 is equal to 5x minus 37. You would then add 37 to both sides. Negative 12 plus 37 gives you 25. You would then divide both sides by that 5 to get x by itself. You get x is equal to 5. The nice thing, guys, about algebra is once you get an answer, you can easily go ahead and take that answer and substitute it in and plug that into your calculator and go, okay, well, here's what this left side is. It says it's negative 3 times parentheses. I would say 5 plus 4, close parentheses, and hit enter. What does it give me? And then I would do the same thing here. I would do 2 times the 5 minus the 37, hit enter. What does it give me? If both of those come out to the same, then you did it correct. It's a lovely thing about algebra. It's self-checking. Okay? Let's take a look at number 6. Number 6, you should have gotten x is equal to negative 2. Here's why. Distribute the negative 2 to the 5 and the negative 2 to the negative 4x. That gives you negative 10 plus 8x. You then have variables on both sides, so you need to add the 3x to both sides. That minus 32 comes down as a negative 32, is equal to negative 10 plus 11x. Now it becomes 11x. You would then add 10 to both sides. That would give you negative 22 is equal to 11x. You would then divide both sides by 11. You get x is equal to negative 2. Okay. Again, you'll find this online tonight. Number 7. You have to do distributive property first. You have to do negative 2 times 9x to get negative 18x, and negative 2 times negative 1 to get positive 2. Then on the other side, you have a negative that needs to get distributed to the x in the minus 9. That becomes negative 1x, or negative x, plus 9. That minus 7 remains unaffected. You then combine your like terms. That negative x and that negative 7x can get combined to create a negative 8x. You would then add 18x to both sides. That gives you a positive 2 is equal to 10x plus 9. And then you would solve from there. Subtract the 9 and then divide both sides by 10. You'll get a negative 1/2 x. Nope. All right. For problem, yeah. Oh my goodness. Thank you. Negative 7. Woo! Miss French-Zheng was trying to move too fast. So negative 7 over 10. Negative 7 over 10 would be our answer. Negative 7 over 10. Okay, let's move on to number 8. For problem number 8, we're going to distribute that negative sign to the 7x and to the 4. That gives us a negative 7x minus 4. We still have that negative 5 that's in front of it. We can then combine those like terms. Negative 5 and negative 4 can combine to create a negative 9. So we now have negative 9 minus 7x is equal to negative 6x. We would then add 7x to both sides to get a positive 1x. So we have negative 9 is equal to x, or x is equal to negative 9. Number 9. We would combine the like terms of 5x and negative 2x first to create 3x. So we have 3x plus the 4 is equal to 6x minus 14. We then move negative 3x to both sides. That gives us 4 is now equal to 3x minus 14. I would add 14 to both sides to get an 18 equals 3x. And then divide both sides by 3, get x is equal to 6. The last one, number 10. We would distribute the negative 2/5 to both sides or to both terms first. That gives me a 1 minus 2/5 x minus 2/5, and then minus that 4/5 x. I then need to combine like terms. I have variable terms I can combine together to give me negative 6/5 x. I have coefficient terms, or not constant terms, 1 and negative 2/5. That gives me a positive 3/5. I would then subtract 3/5 from both sides and then divide by 1/5. I get x is equal to 3. You have a delta math. It is due when? Thursday by the end of class. You need to make sure that you are not postponing or procrastinating. Don't forget to finish that IXL as well. You also had those multi-step equation mystery picture that's due Thursday as well. Please don't forget to show your work for that. You're turning that in on Thursday. Pack up. Oh, wait, no, you don't have to pack. Oh, well, yeah, pack up. Go ahead, pack up.
No, I'm talking about